Key concept 11, target D.
Yeah, YouTube channel is at Math Videos by Mr. A. Make sure you subscribe so that way you know when new videos come out. Hit the notification button as well. I'll be making videos for Key Concept 6 through Key Concept 14 for Integrated Math 1 Core and Honors.
All right, target 11D is still talking about quadratic functions, but we've been looking at standard form for the first three targets, A, B, C. Now we're looking at a new form, which is called vertex form. Vertex form is f of x equals a times the quantity x minus h raised to the second plus k. Now, the benefit with vertex form is in the name. You can easily identify the vertex. So if you think back to target 11A when we first started talking about what a quadratic looked like and the graph is a parabola, if the parabola opens up, the vertex is the lowest point, also known as a minimum. If the parabola opens downward, the vertex is the highest point, also known as the maximum. Okay, in this case, HK is going to be the vertex. Now, you'll notice that H is inside the parentheses. The formula says minus H. So we're going to take the opposite of whatever H we see inside the parentheses. So if inside the parentheses it says X minus 5, then H is going to be positive 5. If it says inside the parentheses X plus 7, H is going to be a minus 7. And then K is on the outside. K we're going to leave exactly as it is. So we're going to say keep it. So if K happens to be positive 10, it's going to stay positive 10. If it happens to be minus 1, it's going to stay minus 1. Okay. If there's no H or no K, there is still 1. You can just assume that it's 0. Okay. So let's go ahead and do example 1. Example 1 says identify the vertex given the quadratic equation. So A is given in standard form. So we're going to write down the vertex. Inside the parentheses, again, is we're going to find H, and we're going to take the opposite. So in this case, H is positive 5, so the opposite would be negative 5. K is located outside. Keep K. So K is positive 2. It stays positive 2. Right. Now, moving on to B. B says same directions. We're going to calculate or identify the vertex. H is inside, opposite. So it's minus 3, it's going to become positive 3. K is outside, K stays the same, so it's going to be a minus 2. So the vertex is 3, negative 2. Now keep in mind, another benefit of vertex form is that you can easily identify how it changes the graph. So we know from before that A is similar to the A here in standard form. And before A told me if we had a parabola that opened up or opened down. That's still true. Okay. H tells us how the graph moves left to right. And then K is going to tell us how the graph moves up and down. If you remember, we did something similar with exponential functions too, where each value in the form made the graph switch a certain type of way. All right, moving on to the next one. Alright, so example 2, we're going to do something called completing the square to make a perfect square trinomial. So I'll briefly explain what it is, but it'll make more sense as we keep doing examples. Trinomial, we already know, is an expression with 3 terms. So something as simple as x squared plus 5x plus 10 would be considered a trinomial because it has 3 terms. Now, it needs to be a perfect square, though. That's where it gets a little bit interesting. A perfect square is something like the number 25. And the reason we consider 25 a perfect square is because we can get 25 by taking some number and raising it to the second power. So for example, 25 is 5 raised to the second. 100 would be another perfect square because 100 is 10 raised to the second power. So we want something, some quantity that when we multiply it by itself, when we raise it to the second power, gives me that trinomial. Okay, so an example could be something like x plus 5 raised to the second. Okay, that's the same thing as x plus 5 times the quantity x plus 5. Okay, if we carry that out, right, so we'll have x squared plus 5x, 5x plus 25. We combine like terms. We end up with x squared plus 10x plus 25. That right there would be considered a perfect square trinomial because it has three terms and it was a perfect square. It was something times itself. Okay, so that's sort of what we're trying to do here. And it'll be useful too in more examples as we go on to help us eventually solve for x. So example 2 says, find the value of c that will make the expression a perfect square trinomial. Okay, we're going to take the directions here that say take the value of b, we're going to divide it by 2, and then square the result. So whatever b is, then we're going to go ahead and divide it by 2, and then we're going to go take whatever that gives us, and we're going to square it. So we're going to raise it to the second power. Looking at it, a, we have x squared plus 22x. So we want to know what value of c would make that a perfect square trinomial, and it's not just any value. So b happens to be 22, just a coefficient. So we're going to try to find c by completing the squares. So we're going to take b, which is 22. We're told to divide it by 2, and then to take that and raise it to the second power. So 22 divided by 2 will give us 11. Keep that in parentheses, raise to the second power is going to give us 121. So the c value that would make this a perfect square trinomial is 121. So if I were, not that you have to, but if I were to go back and plug it in just so you can see what the perfect square trinomial looks like, it would be x squared plus 22x plus 121. Okay, moving on to B. Same set of directions, different problem. So we're going to try to find the value of c that would make this a perfect square trinomial. We're going to take b, which happens to be 10, divided by 2, and then square that. So 10 divided by 2 will give us 5. Remember, keep that in parentheses, raise it to the second, gives us 25. Now, it's very important that you keep leaving those values inside the parentheses because that whole answer needed to be squared, all right? And if there's a negative, we need to make sure that negative is inside the parentheses to begin with. So we find out that the c value that would make this a perfect square trinomial is 25. And again, you don't need to do this last step, but just to show you what it would look like if we plugged it back in, we would have x squared plus 10x plus 25, and that is a perfect square trinomial, which means both of these are going to be equal to some quantity raised to the second power or multiplied by itself. Now, that c, when we complete the square, this c right here should always end up being positive when you do everything correctly because you're eventually going to raise it to the second power. So let's say c was 7 to begin with, right? Positive 7. If you take positive 7 in parentheses and you raise it to the second power, you're saying 7 times 7, a positive times a positive, which would give you positive 489. Let's say it was a negative 8. Negative 8 raised to the second power, making sure that negative 8 is inside the parentheses, is the same thing as saying negative 8 times negative 8. And a negative times a negative would give you a positive, which would make c positive 64. So when you complete the square, if done correctly, should always give you a positive value. All right, so we're moving ahead a little bit. Again, these will make more sense, I think, when it's example 5, I think we get to, where we're sort of going to put it all together. But right now, the directions say determine the value of c in order to solve by completing the square. So we're completing the square, which is something that we did in example 2. We're moving towards trying to solve it, but not quite yet. Right now, they're just asking us to find the value of c. Okay, so first things first, you want to make sure that your equation is in standard form. So ax squared plus bx plus c equals 0. Sure enough, it is. Now, the next thing you want to do here is you want to leave everything that has an x together, and you want to get that constant, that c, out of the way. So we're going to have to move it to the other side of the equation. Now, we already know that what we do to one side, we have to do to the other, and c is currently a positive 5, so to get rid of that, we're going to have to subtract 5 from both sides. Okay, 5 minus 5 on the left will cancel, leaving us just with x squared plus 22x. 0 minus 5 is a negative 5, which is exactly what we have there. Okay. The next step we're going to do here, we're going to find c, so we're going to complete the square. So we're going to take b, divided by 2, and raise it to the second power. Now, b happens to be 22, so we're going to take 22, divided by 2 in parentheses, and we're going to raise that to the second power. So 22 divided by 2 is 11. 11 squared is going to give us 121. Now, you could probably do that in your head or in your calculator very easily. The reason I want you to write it out is because later on, not yet, later on, you're going to see that this value right here is actually pretty important. So, determine the value of C. In this case, we found out that C was 121. Okay. Not that you have to do this, but just to show you what would happen if we plugged it back into both spots where it's supposed to go. It would look like this: x squared plus 22x plus 121 equals negative 5 plus 121. Okay, and we're just going to stop there. We didn't even have to take it to that last step. The answer was actually this. I just wanted to show you that you can plug it back in, because in the next example, that's sort of what we're going to do. All right, moving to example B. And same directions, making sure it's in standard form. So ax squared plus bx plus c equals 0. Sure enough, it is. We want to get the x's on one side and get rid of this c by moving it to the other side. So we're going to have to get rid of the minus 6 by adding 6 to both sides. On my left, negative 6 plus 6 will cancel, so we can bring down x squared plus 10x. On the right, 0 plus 6 gives us a positive 6. Perfect. Now we need to do what's called complete the square. So we're going to take the value of b, which happens to be 10, the coefficient, divided by 2, and then whatever that gives us, we're going to square it. So 10 divided by 2 will give us 5. 5 squared will give us 25. So this c value should be 25. C equals 25. That would be the final answer. But again, just to show you what it would look like if we plugged it back into where we were supposed to, it'd be x squared plus 10x plus 25 equals 6 plus 25. Example 4. It says determine the next step when solving by completing the square. So again, same process, but we're taking it one step further. So first things first, we're given an equation in standard form: ax squared plus bx plus c equals 0. And remember, just like before, we want to get the x's by itself. So we want to get rid of this positive 5 by putting it to the other side. The way we're going to accomplish that is by subtracting, since it's already positive. On my left, 5 minus 5 is 0, so we're left with x squared plus 22x. On the right, 0 minus 5 gives you negative 5. All right, then from here, what we're going to want to do is complete the square. So we're going to take b, which happens to be 22, divided by 2, and then square it. 22 divided by 2 is 11. 11 squared is going to give us 121. So sure enough, they added 121 to both sides. Remember, that was our c from before. And then you'll notice here, they left the left side by itself, but what they did on the right was they combined like terms. A negative 5 plus 125, or sorry, a negative 5 plus 121 is going to give you a positive 116. Now, the next step, we want to take this x squared plus 22x plus 121, and we want to factor it, which is something we did in a previous target. So we want to break it up into two quantities to see what two quantities got multiplied together to give me that product. Now, I'm going to do it the long way, but you're going to see that there's a bit of a shortcut too. Once you understand the long way, you can take the shortcut. So let's take x squared plus 22x plus 121. And we're going to factor it out like we did in a previous target. So we want, that's A, this is B, C. We want two numbers that when we multiply them together, give me C. But when I add them, give me B. Keep in mind, C here is 121, B is 22. Now, you can come up with all the factors of 121. Hopefully, by this point, you're getting a little bit better at identifying those factors right away. So we'll say the two numbers that multiply to C to give me 121 will be 11 times 11. But I also want them to add up to 22. 11 plus 11, sure enough, gives me 22. So I can break this up into two quantities. X has to be the first one in each case so that I end up with x squared. And then the two numbers were positive 11 and positive 11. So this trinomial right here ended up factoring out to x plus 11 and x plus 11. Okay. However, there's another way we can rewrite that, right? It's the same quantity being multiplied by itself. So we can say, all right, take x plus 11, and then how many times was it multiplied together? Twice. It was squared. It'd be the same thing as saying 5 times 5 is the same thing as 5 raised to the second. So I'm going to rewrite this left trinomial as the quantity x plus 11 raised to the second equals, I'm not doing anything to the right, so I just bring it down as 116. Notice that right here, this was a perfect square trinomial because it has 3 terms and it ended up being the same quantity being raised to the second power, also known as a perfect square. Now, you could do it this way, but it's a little bit long. There's a way that you could have come up with this right away. If you remember from the previous example I told you, when we were completing the square, when you take b divided by 2 and raise it to the second power, I told you to write it all out because this number right here would be important. This number is going to be the one that goes inside the parentheses. So it's always going to be x plus or minus some number raised to the second. This number right here will always be when you take b and divide it by 2, which is this number right here. Okay, before you square it, but after you divide it by 2. So that's the shortcut. So you should be able to go from this step right here to the next one very easy if you use the b divided by 2 answer from before. All right. I think it'll make more sense as we do more examples. But again, if you're uncomfortable with the shortcut, you could keep doing it the longer way. Just know that that shortcut is out there available for you. All right, in example 5, we sort of put it all together. So steps to rewrite standard form into vertex form. So we're going to go from standard form and we're going to rewrite it in vertex form because in vertex form it's a little bit more convenient to find stuff. So first step here, must be in the form ax squared plus bx plus c equals 0, or instead of 0 it's equal to f of x, or it's equal to y, which is all the same thing. We look at this equation right here, y equals x squared minus 20x plus 95. Sure enough, it is in standard form, so we can move on to step 2. Step 2 says add or subtract to get all the terms with x on one side. So we have x squared minus 20x. We want to get that by itself, so we need to get rid of that positive 95 to the other side. It's positive, so we're going to have to go ahead and subtract 95 to both sides. Okay. On my left, we have y minus 95, which are not like terms, so we just write it down. Y minus 95 on the same line. On the right, 95 minus 95 will cancel, and we'll be left with x squared minus 20x. So we finished step 2. Step 3, complete the square. So we're going to take b divided by 2 and square it. And then whatever c value that gives us, we're going to add it to both sides. So b is negative 20. Okay, so we're going to take b divided by 2, and then whatever that gives us, we're going to square it. Negative 20 divided by 2 is negative 10. Negative 10 in parentheses raised to the second power is going to give us a c value of positive 100. So we're going to add 100 to both sides. So we're going to have y minus 95 plus 100 equals x squared minus 20x plus 100. Okay, a couple things we can do here now. On the left, we can combine negative 95 with 100 because they're like terms. So that'll be y plus 5. On the right, this is step 4 actually we're looking at right now. Step 4 says factor the perfect square trinomial and combine like terms on the other side. So we already combined like terms on the other side, on the left side. Now we need to rewrite this perfect square trinomial as some value times itself. So remember, that's always going to end up being some quantity raised to the second power. X, because that's the only way we'll get x squared. And then the number that goes inside the parentheses, remember, is this one right here when we took b and we divided it by 2, which is minus 10. Okay. Again, if you feel more comfortable doing it the longer way, you're welcome to do that. Now, it's not quite in vertex form because if you remember correctly, vertex form should look like y equals a times the quantity x minus h raised to the second plus k. So y should be by itself. So y is not by itself quite yet in this equation. There's a positive 5 in the way, so we're going to subtract it from both sides. And then what we have here, plus 5 minus 5 cancels. We're left with y equals the quantity x minus 10 raised to the second. And then at the end of it, minus 5. This right here is vertex form, and it's my final answer. Okay, so we did step 5, which was add or subtract to get into vertex form. Now, that yellow part is your final answer. Keep in mind, if I wanted you to find the vertex at this point, you could. I'm not asking you, but just know that you could. Remember, opposite of H, keep K the same. All right. All right, example 6, we're adding another step to it. We're now solving the quadratic. We're not just rewriting it. So in the previous example, we had to go from standard form to vertex form. We'll still need to do that to solve it, but this time we're going to take it one step further and we're actually going to solve it. So you'll notice steps 1, 2, 3, 4 are not bolded, and that's because they're the same steps from the previous example. But step number 5 and 6 is bolded because those are two new steps that we're going to have to add. So first step says to make sure that it's in standard form. We have x squared plus 18x plus 17 equals 0. Sure enough, that is in standard form. So we can move on to the next step. So far, so good. Step 2 says add subtract to get terms with x on one side by themselves. So we have x squared plus 18x. That has x's, but 17 does not. So I need to get 17 to the other side. It's positive 17, so I'm going to have to subtract 17 from both sides. And that's 17 minus 17 will cancel. We can bring down x squared plus 18x equals 0 minus 17 is going to give us a negative 17. So we're done with step 2. Step 3 says complete the square. So we're going to take b, divide it by 2, and then raise it to the second power. B happens to be a positive 18. So we're going to take 18 divided by 2, close it up, raise it to the second power. 18 divided by 2 is 9. 9 squared is going to give us a positive 81. So we're going to add that 81 to both sides. So now it's going to give us x squared plus 18x plus 81 equals negative 17 plus 81. Right? And that was step 3. So we can move on to step 4. Okay, so step 4 says factor the perfect square trinomial. Remember, there's a shortcut to do this. On the left, this should always equal some quantity raised to the second. X will be the first one, and then remember when we took b and we divided it by 2, we got 9, so that's going to be a positive 9 that goes in there. And on the right, negative 17 plus 81 are like terms. We add it, we get 64. Okay, moving on to step 5, which is a new step. Step 5 says to take the square root of both sides. Now, we haven't seen that yet, but when something is raised to the second power, the way we undo it is by taking the square root. So let's say, I'm just going to call this scratch work. This is not part of the problem. I just want to show you guys something. Let's say we have something like 5 squared. If I want to undo that squared, I just need to take the square root. And that's because 5 squared is 25, and the square root of 25, perfect square, is just 5. So I got rid of that exponent by taking the square root. It's like when you add by 5, you undo it by subtracting by 5. When you multiply by 2, you undo it by dividing by 2. When you raise something to the second power, you undo it by taking the square root, right? The index would be 2. That's what would cancel it out. So step 5 says take the square root of both sides. So we take the square root of both sides. Now, you don't need to do this. Again, I'm going to put it under scratch just so that you can see it. Technically, what we have here underneath the radical, x plus 9 raised to the second power, is the same thing as x plus 9 times x plus 9. And remember, the index in a square root is 2, which means we're looking for pairs. Here's a pair. So when we take the square root of this entire thing, one of them is going to come out, but they'll both cancel. All right, so going back over here, the square root of the left is just going to give me x plus 9. On the right, square root of 64. You could take the square root of 64 and create a factor tree, but eventually you'll find out that it's just 8 times 8 because it's a perfect square. There's my pair. I'm going to take 1 out. Now, the only thing here, too, that we also haven't talked about is technically 8 is not the only answer. I can make these both negative, and they would still multiply to give me a positive 64. So the answer is not just positive 8, but it's also negative 8. So we can take out a plus or minus negative 8. Okay, and then the last step here says solve each resulting equation. There's more than one equation here. The first equation is x plus 9 is equal to a positive 8. And the next equation is x plus 9 is equal to a negative 8. So we really do have two equations that we need to solve for. You subtract 9 on the first one. Turns out x is equal to negative 1. One of my answers. Looking at the second equation, you have to subtract 9 here too. And then you find out that x is equal to negative 17. So those two right there are my final answers. All right, so we're moving on to example 7, which is similar to the one we just did. It's just a word problem, so we're going to probably have to explain our final answer in terms of whatever the problem was talking about. So, example 7, the number of bacteria n in millions in a refrigerated food is given by the function below, where T is the temperature of food in Celsius. Use the completing the square method to determine the temperature where the population of the bacteria will be at a minimum and the corresponding number of bacteria. We got a lot of interesting stuff going on here. So we're obviously still talking about quadratics. We're talking about a minimum, which tells me that I have a parabola that opens up and I want to find the vertex. Okay, so I want to get it in vertex form, which is y equals a times the quantity x minus h raised to the second plus k. However, if you look at the equation they gave us, that's standard form. That is, let me write it down here just in case we forgot it. Standard form, which is basically y equals ax squared plus bx plus c. So they're asking me to go from standard form to vertex form. What's even trickier here is they don't use the variables y and x. They use t and n. Okay, so normally we're used to x, y, but now they use t and n. Notice that t is in the spot that x is usually in. So x is no longer x. X has been replaced with the variable t. And then notice that n is where y would normally be. So y has been replaced with n. So when we find our vertex, we're really looking for t comma n. All right. Okay, so first step, we're going to have to get everything with t by itself on one side. So we'll leave that here, but we need to get rid of the 66. It's positive. So what we're going to have to do then to undo that is subtract by 66 on both sides. So on my left, we're going to have n of t equals, n of t minus 66, right? Because we couldn't combine them. They're not like terms. And on the right side, we're just going to be left with t squared minus 8t. Okay. Then we're going to have to complete the square. So we're going to take b, which happens to just be negative 8. And then we're going to have to divide it by 2 and then square it. Negative 8 divided by 2 is negative 4. Negative 4 squared is going to give us positive 16. So we're going to have to add 16 to both sides. So we have n of t minus 66 plus 16 equals t squared minus 8t plus 16. Now, on the left, we can combine like terms. We can do negative 66 plus 16. Okay, so that's going to give us n of t plus 50, or sorry, minus 50. Right, because negative 66 is the greater amount. And then on the right, remember that's going to just some quantity raised to the second power. The first one will be t, not x, because x is not in this equation. And then what's going to go in next to the t is that value right there, minus 4. Right, when we complete the square and we took b divided by 2, we get negative 4. That's the value that goes inside. That's the shortcut. Now it's not quite in standard form because y, or in this case n, should be by itself. So we need to go ahead and get rid of this minus 50 by adding 50 to both sides. So final answer we're going to have here is n of t equals negative 50 plus 50 cancels. We have t minus 4 raised to the second, and then a positive 50. Okay. Now, keep in mind we're still solving a word problem, though. What we really wanted was the vertex. We wanted to know where it was at a minimum. So the vertex here is going to be opposite of h, positive 4. Keep k the same, positive 50. But we also need to determine what that means. Okay, so it says right here, use the completing the square method to determine the temperature where the population of bacteria will be at a minimum and the corresponding number of bacteria. So T was a temperature. So the temperature here is 4 degrees Celsius. So at 4 degrees Celsius. And then N was the number of bacteria in millions. This is N. There will be 50 million bacteria. So at 4 degrees Celsius, there will be 50 million bacteria. So that is truly our final answer. All right. I skipped example 8. Example 8 should have been very similar to example 7. The only difference might have been that you ended up with decimals. You can still do it with decimals. In that situation, I would say normally I have you guys leave decimals as simplified fractions, but in this case, it might actually be easier to work with decimals. So I will leave your answers in decimals for number 8. Number 9 is a bit of a bonus. We did this already, so we're looking at rewriting standard form to vertex form. We did that already. The only difference here that we haven't done yet is A is not 1. Okay, so let's see what that would look like. First things first, must be in standard form. We have y equals 2x squared plus 16x minus 18. Sure enough, that's standard form, so we're done with step 1. Step 2, add or subtract to get all the terms with x's on one side by themselves. So we want to get this right here by itself, so we're going to go and add 18 to get rid of minus 18 to both sides. On my left, we have y minus 18 equals, on the right, we're going to have 2x squared plus 16x, and then negative 18 plus 18 cancels out. So we're done with step 2. Step 3 says, factor out the greatest common factor from the coefficients of the two terms containing the variable x. So from 2x squared plus 16x, we want to figure out what they have the most in common, the greatest common factor. We did this in a previous target when we had 4 terms and we split it in half. So on the left side, we're going to leave y minus 18 the same. But on the right side, between 2x squared and 16x, I want to know what's the biggest thing that they have in common that we can factor out or divide out. They both have an x, so I can take out an x. However, we actually don't want to take out an x. My apologies. I didn't read the steps correctly. The step here says factor out the GCF from the coefficients. So we're really only looking at 2 and 16. I'll explain in a little bit why we don't want to take out an x, even though they both do have an x in common. So between 2 and 16, the most you can take out is 2. When we do that, we'll be left with x squared plus 8x. Now, the reason I didn't want to take out an x2, even though I could have because they had an x in common, was because I still want to create the perfect square trinomial. So I want to complete the square. And in order to do that, I need to have an x squared, so I can't take one out. So step 3 says, complete the square. Divide b by 2, square the result, and add this value to form the perfect square trinomial. Okay, so b right now is positive 8. So we're going to take 8 divided by 2. We're going to raise it to the second power. So 8 divided by 2 is going to give us 4. 4 raised to the second power is going to give us 16. Now, here's where you need to pay very close attention to, because this is the little tricky part that gets a lot of students confused. On the left, we still have 2 on the outside. And the inside, we have x squared plus 8x. And sure enough, what we're adding there is a positive 16. Okay, and then you can close up the parentheses. Now, technically, we did add 16 in the inside, but we need to account for the fact that it's 2 times whatever's in parentheses. So 2 times the 16 inside is actually 32. So on the left, we had y minus 18, but instead of adding 16, we're actually going to add 32. And again, the reason for that is because there was a 2 on the outside, and 2 times 16 in the inside is actually 32. So it says multiply this value by the greatest common factor from the previous step, and add subtract it to the other side. That's exactly what we did there. Now, factor the perfect square trinomial and combine like terms on the other side. So on my left, we have y minus 18 plus 32. So we can combine 32 and 18, negative 18. We're going to get a positive 14 equals. And then on the right, we still have 2 out there. But x squared plus 8x plus 16 is a perfect square trinomial, which is going to be some quantity raised to the second. Here's x. It's going to be this number, b divided by 2, so positive 4. And then the last thing we need to do is get y completely by itself. Right now, there is a positive 14 in the way, so we're going to have to subtract 14 from both sides. On my left, 14 minus 14 cancels. We're left with y. On the right, we have negative 2 out front, quantity x plus 4, raised to the second, and then minus 14. So this right here would be our final answer. Okay, that is, we went from standard form, and then now we rewrote it in vertex form.